Okay. So first, what are data types? So generally, in any programming language, right? So when you're working with the variables or any type of data, right? We need holders for different types of data. So data can be integer types or decimals or right any text format, paragraphs, single characters or some flags, or it can be anything. So we should have a data holder for any type of data, and we have few types in .NET, right, using which you can hold any type of data, right, for logic layer, right. So on top we have these primitive types mainly. We have integer, we have decimal type or normally called as float type, right. We have Boolean type. These are the main high-level primitive types or high-level data types we have, right, in general. So basically, along with float, right, so sometimes we also call decimal as a separate type. But in this, decimal always includes the float, but that's fine. So normally say that something which always be taken, under which you have multiple vectors. So here, so these are the high-level primitive types we normally call having. So let's understand the actual data types which we normally use in our real-time integrated life. Right? So under integer we have these data types. We have a byte, we have a SByte data type, right? And you have a short, and you have a U short data type. You have int, and you have U int data type. You have long and U long, and then you have a char. Now let's understand this what exactly are these, and then we'll see. We'll actually see it programmatically how it is once we learn the complete set of data types. Now here, see when we talk about any data type, right? It's important to understand what size it can hold, right? What different data with different sizes, right? So definitely there will be different size for different data we normally mention. So when I say simply like 5, right, which is a simple number 5, okay, it may take just a few bits to accommodate, or a single bit to accommodate, for example, right? But when I say a number like this, right, then you can understand that it is not just a bits, not even byte, right? Not even a convention of multiple bytes, right? It may take more, maybe in MBs, to save this data. So it all depends on what data we are actually taking up. So here, understanding of a memory convention is very important. Right? So here, when we talk about memory convention in our software terminology, the least memory convention type we have is bit, right? So which is always a sorted one, which either takes 0 or 1, and it's a bit type. You know that 8 bits, right, is a byte, right? So 8 bits makes 1 byte, and the minimum convention which we use for data types is a byte convention, right? Yeah, we have for few, yes, we do have a bit convention too, right? But we'll see that. But we normally take up something called byte convention to actually refer to, okay, this data type is so many bytes, this data type is so many bytes kind of. right? So let me just ping on. Right. So in this way, you have 1 byte where I can say your 1000 bytes makes a KB, which is 1 kilobyte. Right? Similarly, your 1000 kilobytes, right, make your MB, which is a megabyte. Similarly, your 1000 megabytes makes your GB, which is gigabyte, and so on. Terabyte and all. So that's why data will not go beyond your GBs, right? Not to TB. If it is going to TB, then yes, it is something which is a completely data project, right? Yeah. So these are memory convention we normally follow, right? So now here, so definitely in one, see, when we talk about integer data type, the main reason behind integer data types is to hold a data or the whole number mainly, right? Which is a positive number, 0 and positive and negative values. That's it. Which is the whole number. Now, integer does not spare to save decimals. Okay, it allows only whole numbers as such. Right? So here, when we say okay, it is going to save whole number, now why do we need these many data types? Right? We just need one to save, right? We can do that. But yes, if you can see more deeper insight into this integer, in real time we normally play around with numbers, right? Most of the times. It can be for a simple loop or it can be for a huge data handling, right, of any big, size conventions or amount conventions or anything you can take, right? We normally play around with the numbers. But definitely here, when I talk about, let's say, a simple small applications, counter applications, right? So it may not even take more than a number 100. Similarly, when I take about savings accounts and account number generations or amount calculation and all, it may go beyond 6 to 7 to 8, 9 digits of a number. Definitely based on that, right? See, when I'm creating a higher memory size data type, definitely it is going to eat up so much of memory whenever that variable is created of that specific data type. Right? So that's the reason why we have these many, and each and every data type here have got its own memory size. Let's see that. Now, first one was byte. Now, anyways, this byte and this byte are not same. This byte is one of the data type in C#. So don't get confused here. This byte is a name, struct name, which conveys a data. So here, yes, this is of 1 byte. So data till 1 byte you can actually create in a byte. Similarly, S byte is again which is called as a signed byte. There is no difference. There is just a difference of one data can handle only positive values, and another data can handle both positive and negative values. I'll show you that. Because of S byte and byte, the range of data will change. Okay, we'll see that. So we have short. Sorry, which always take 2 bytes of data, and the U short, which is called as the unsigned short. Again, see, whenever you have data, you can see in different modes here. Byte and S byte, short and U short, and int and U int, long and U long. On high level, you can see there are 5 types: byte, short, integer, long, and char. And your unsigned and signed integer is something which is used to save positive values only, and another only so positive values anywhere you can save both positive and negative including 0, kind of. That was it. So you have U short, which is again 2 bytes, and again you have integer 4 bytes, right? You have new integer, which is again your 4 bytes you have. Right, you have long, which is 8 bytes. Okay, so you have your U long. Sorry, you have U long, which is again okay. right? And we have a character, right? So you may wonder why character is here. Character is again 2 bytes, right? See, character data type, right, is used to say character or a single character, right? And whenever you say any single character, internally the ASCII number of that character will be saved, right? So that is the reason why it actually it is divided under your integers basically. That's the main reason. There is no big reason behind, and it can save data till 2 bytes, right? So that's your character. So these are your integer data stream, right? Which can save the. Let's go to the next one, which is our float, right? And basically, with the name itself, you can understand that float is a type which can save decimals, both float and decimal. So, or if you want, I can also remove the decimal because we can talk about decimals directly under float. So, under float, we have a data type called float, which is of 4 bytes, right? And then we have mostly used one, double, which is of 8 bytes, and then you have the last one called decimal. This is the biggest size one, 16 bytes, right? So decimal can save data till 16. So this is what we have, right? So where we can actually save data, right? And float, when we talk about float data types, right, it can save any real number as such, positive, negative, decimals, and so on. That's a float data. And then coming to the next one, which is a boolean. So boolean, we have a data type called bool, which is a flag type mainly, right? So it is of size 1 bit mainly because the allowed values for this bool is true, either true or false, right? So internally, when it is true, right, 1 is saved, and if it is false, 0 is saved. That's why boolean is a bit type, which is 1/8 of the byte, right? So it is just used to convey if it is 1, okay, make it as a true. If it is 0, make it as a false. That's your boolean. And then you have something called string. Now string doesn't have any memory limitation. String can go as much data as you can feed. That's the capacity of the string, right? It can go on, and anyways, it depends on the virtual memory, how much virtual memory we have. Right till that point, yes, string will work. These are the consolidated list of data types we have in .NET. Right. So let's take some of these and let's understand, right, how to define a variable. So we have understood what is a class, right? And now we are going to understand what is a variable, right? Well, in order to understand a variable, what do we need? We need what is the data type, simple. Right? So when we say what is the data type, okay, these are the data types which we have, and then now what we can do? Now we can actually understand what exactly is a how do we actually make how do we actually use these data types to create a variable? Right? That's what we want. So let's see that. So now let's get back here. So we have created so many classes, right? As such, and we have actually created so many folders, right, where we have actually used something called namespace concept. To understand namespace concept, we have actually created so many folders where you can see that namespaces always are important, right, to actually modularize all our classes basically. Fine. So now let me create a new class. So what I'm gonna do, I'm gonna create a new class, and I'm actually going to create a static main method in the new class, and then we'll see how to do it. So let me create a new class here. Use all documents. Right? Let me right click on this and say add new class. Right? So it is gonna take so very quickly, guys. So my system is okay. Fine. So now what we are going to do? So we have created a class, separate class called datatype, in which we have defined static main, right? But we have seen that already there is a program or a class, separate class written called program.cs, where main is already defined. So now we have a conflict in these two mains. Now when I run my program, definitely I should mention the program saying, okay man, there are two different classes, but take this class for starting the program. Now how to define is, we have to go to properties. Okay, now we are in properties. There you have something called startup object. So what it will do when you compile your program or project, right? So automatically, whatever classes have main method. As of now, you can see we have data types with static main, right? And you can see that the main is wrong here. It should always be capital N, right? So when you save it, go back here. When you look at it, you can see now you will be able to see both the program and data types have a main method. So this syntax is very important. So we actually mentioned main as small m intentionally, so that you can see that if something is not defined correctly, then that is not considered as an actual startup main method. That is very important. Fine. So now you can see, okay, you have to what you can do, you can select any one of them. Okay, let's say data types. Okay, so tomorrow maybe I have 10 different classes with main, then you will have all the objects defined here, all the 10 different objects defined here with a main. Right? Yes, this is not a blocker. You can go ahead with classes with multiple statics, main classes defined, but that is generally not a best practice. So what I'm going to do here, so I'm going to follow the same convention always throughout my training, right? So as we're going to create multiple projects and multiple classes altogether, what I'm going to do, I'll just remove the static keyword. So as soon as I remove the static keyword, what will happen? This is no more a actual main method, right? Because in order to create an actual main method with the static triggering main method, I should always have a convention static void main with a synchronous. This syntax is this syntax is the one which is always standard. Something goes wrong here, some keyword or some thing is not defined correctly, then that will not be a main. So now let's get back here and see. You can see. So anyways, there is only one data type now. So now anyways, now we can say that okay, program doesn't have any main. So I have main only for data type. Simple as that. Now this is mine. This is how we are going to create all our classes. Fine. So this is how we are going to create our main. So anyways, now we know okay how to create a main. So here first let me always say read line. So always I'm gonna create this read line first because whatever we are actually printing up, right? We should wait the console until we work with all the output, and then we can actually provide input to console so that it can stop or close the program. Simple as that. Now let's understand how to define a variable. So we'll go one by one. So let's take integer, which is byte. You can see as is typing will always get a instance, right? Byte is a data type we have, which is of integer type and takes 1 byte of memory, right? 1 byte of memory to save the data. So let's say I'm gonna say byte. So this is how we normally define a variable. So you have a byte. B is a variable. You can give any name you want. Now this name is of type byte, and I can give is equal to value called let's say 10. This is how we define a simple variable. Now here, what is happening? Now 10 is my value input, and I want some variable to save my value called 10. For that, what we have done, we have created a variable called b of type byte. Simple as that. Okay, and the value will be saved into b. Fine. So this is how we normally define a variable. So now let me print it. So let's say I'm going to print console dot write line. So what I can do, I can print b directly because we know that this is a variable name, and variable name can be called up so that whatever I'm saying. So here what I'm doing, I'm actually saving the data, and here what I'm doing, I'm trying to retrieve the data. That's it. Let's run this program. So when I run my program, what it will do, it will print just the value of b. Okay, you can see the value is 10. Now this is the value which we have actually defined for a b, right? Which comes to byte. Now, so while learning byte, we also had something called s byte, right? You can see s byte. Let's say sb is equal to let's say 90. Now here, so you can see that both the data types, right? I have actually mentioned positive values. Now, anyways, we know that if you don't mention any sign, it is by default positive. So let's say I'm going to define negative values. You can see when I say minus and minus for both and save, you can see that it will give error to byte because s byte, which is signed byte, very important. This is something which is called as a signed byte, right? Which means when it is signed byte, which means there is a separate slot where it will save the sign. That's why s byte is allowed to save negative and positive values, whereas byte is you can say byte as an unsigned one. So it won't allow any negative values, just from 0 to h. Now this is how it is. Two things to understand here, right? Now as soon as I actually save it up, right? So we have already seen something called error, if you remember. Now here you can see we have a green underline under this variable, right? So if you go to run this window again, there is a window which we have already seen, right? There is second slot called warnings. Click on it and you can see it says the variable sb is assigned but its value is never used, which means this variable is anyways you have defined but you are not using it. That's a warning. It's not an error. Even if you don't solve it right, the program is not going to stop. But what is the problem here? Problem here is always try to solve warnings because see, if you're defining a variable and if you're not using, then there is no meaning in defining that variable, right? Because this simple variable is going to consume 1 byte of memory, which is of no use. And just consider if you're creating these type of variables which are not used under across 100 different classes, 100 different times, then you can imagine that how many memory of how many bytes of virtual memory we are eating up unnecessarily, and it does cost to the customer, which we don't need, right? That's why anyways, for now I'm not going to remove, because we're going to plot all the data types, right? So that's why. But yes, this is a warning which you can see, and warning is not a mandatory blocker which Visual Studio will give, but yes, as part of performance and the best practice, we normally try to solve most of the warnings, and few things which we can't solve and which you have to keep it as is, then we can't. Anyways. Now the next one is a short. You can see here a short, maybe ST is equal to let's say I'm taking some 54. Similarly, U short. Now here the convention is different from byte here. Right? Yes, both we are saving, but now let's put our negative values. You can see now here for a short, U short will not take a negative. Why? U is not put unsigned. But very so unsigned meaning okay, the sign is not allowed in an unsigned variable. Simple as that. Now U short will not take a negative value, whereas a short will take a negative value. So from here it's the same. So when you go to next one, let's say integer int I maybe is equal to some 100, and U int is maybe UI is equal to some 120 something. So here your U is unsigned, so only integer will take a negative values. Simple. Similarly, you have long, right? L is equal to maybe 908. Similarly, long UL is equal to some, sorry, U long. Right? Whereas your long can take negative values and your U long doesn't allow. These are your integer types. Similarly, you have char. So while defining chars, right, characters are always defined in a single quotes. Let's say I'm going to give A. Right? So this A is defined in a single quote, which is a character. Now I can't mention two characters within a single quote, which is not a character, it becomes a string, and we are not supposed to create a string or save it in a character. Very important. Right? Now this is something which is important that to mention one. Either you can use special characters, doesn't matter. You have to always mention one character to save it in a character. Right? So this is about your character typing. Right? Similarly, when you print it, right, let me just print C. Right? It will not consume this double quote, the single quotes actually. It is just a convention, but internally the value which is saved is percentage. You can see it's a main value is percentage. It's not single quote. Single quote is a convention to define a character in .NET. Simple. Right? Similarly, you have float ones. So there is something special about floats, which is a decimal type. By default, whatever decimal number you create in .NET is double. Right? You understand what I am saying. So let's say I'm first start with double. I'm not starting with float or decimal because there is a reason. So let's say I'm going to say double D is equal to 9 some values. Right? Now it will take. There is no here. I think when I print on D, when I run this program, you will see the decimal value being saved. So any decimal number you define in .NET is a double, I say. You can underline this statement. Now let's go and say float f is equal to some decimal value. Right? We know that float is used to say decimal. Now you can see you get an error. Why? Because again, let me repeat the statement again. Whatever decimal value we define in .NET is double-sided, which means here what we are doing, we are trying to assign a double value to float. Simple. Which is not which will not happen directly, right? So we have to take a separate route to this to mention, okay, this can we can assign a double value to float. In order to actually assign just this, right, you can see this red line is a error, right? If you open this error, you can see this error, you can understand. So your red line, see, when you haven't built your program, it will show a red line. But if you build your file, and if you're getting, it will turn to blue. Both are same. I mean, both are error. Simple. Okay. Now it says that literal order double cannot be implicitly converted to float. It means that, see, we are not even defining double here, right? But why is it saying double cannot be implicitly converted? Because